You know, Matthew, I've decided. I've made up my mind. The evidence is apparent that I just have to admit it. I've been a round earther my whole life, and my eyes have been opened by the internet. The earth is flat. It just has to be.
I think you're wrong. It's flat, Joe.
Yeah, well, that's what I said. It's flat.
Oh, I thought you said it was right.
No. I said I've been a round earther my whole life,
Oh.
and the evidence of the internet has just convinced me. It just has to be round. I mean, if you just look, look. See my hand?
Mm-hmm.
Oh, hold on. The stream's. I always forget to do that. Look at my hand.
Yeah.
Is that round?
There's curves.
That's flat. That's flat. Now, if I walk on the hand, it's also flat. Look at the ground, Matthew. The ground is flat.
Yeah.
Look at the horizon. There's no curve.
None.
Perfectly flat.
Perfectly flat. No, I think you're right.
I think I'm right.
So much confidence.
Oh, I'm so sorry. I'm really not, but it's kind of funny. Obviously, we're being a bit facetious.
Joe's just giving his real side to you guys,
Exactly.
and then covering up
Yes.
to give you his false side. So
Yeah, I'm actually being paid by NASA to tell you the Earth is round. So anyway, welcome back to the AstroCast. Season 2. This season we're going to be doing something called Astronomy Meets. Today's episode is Astronomy Meets Conspiracy. And we're going to do a couple of these conspiracy episodes. And the first one we're starting with is the Flat Earth Society. So it's going to be a fun episode. And then when we run out of flat earthers to debunk, we're then going to transition over to philosophy. And Matthew doesn't know yet what's going to happen in that section.
I'm scared.
And he will find out.
Mm-hmm.
All right. So why don't you bring up the first article, and we're going to very carefully dissect this intelligent document. Intelligent. Keyword being there.
Mm-hmm.
We're going to carefully dissect it, bit by bit, and I'm just stalling time until I can see it on my screen.
Oh, okay. You want me to read it for you?
No. We've got it in a second. It'll be a few more minutes. I'll just keep stalling. Okay, there we go. So, yeah, we're going to go to... which one? Oh, you clicked on the wrong one. That's okay. We can do that one.
I thought you wanted
No, we can do that one. That one's good.
Okay.
All right, hold on. I'm bringing it up. Okay, hold on. All right. So, why can't we see all of the continents of the Earth from the edge of space?
Oh, you have to say this in the viewpoint of a
Oh,
flat
okay.
earther.
Okay.
Remember, you're saying that because if you're a flat earther, you can see all continents.
Okay,
right?
yes.
Yeah, okay. You gotta
Okay.
say that. Make sure you have the right perspective.
So, I'm a flat earther, right? And I'm going to now be debunking the round Earth theory. So, some may say, well, on a flat Earth, why you would be able to see all of the continents from the edge of space, right?
Mm-hmm.
But, however, the observer is looking downwards at the circle in the sun's spotlight. And, is desktop audio muted? It's not?
Yes.
Okay.
We're good.
That's good.
I saw the bar all the way up.
Yeah. So, for those of you... Oh my gosh. My text messages are appearing on screen.
It's fine. There's nothing personal on it.
Okay.
I read through.
Alright. Let me put my phone on Do Not Disturb. Stall for me.
Alright, I got you. Trust me.
So guys, I was trying to find community tabs. I think they only realistically hide in Facebook, where they talk there's genuine people who believe in the flat Earth theory, and because you already know if they went out publicly with this on their public pages, they'll get ridiculed and stuff. Although there are brave souls who do venture out and do make it public that they are flat earthers and will stand their ground.
Like me.
Like Joe over here. There's not a lot of them. And when you do look up flat earthers on community tabs or such, most of the time it's just news sources talking about one or two that they found. So they don't make themselves readily available to be made fun of.
Well, it's not just that. It's that most people realize that the Earth isn't flat because, you know, it's this thing called common knowledge. And I know these days most people don't have common knowledge. What the hell? What is that?
It's the messages.
More text messages? Okay, hold on. Stall for me again.
I got you.
Where were we? Sure thing.
Here, switch it just to you.
Just to me?
Yeah. You don't need the mouse.
I don't? Oh, yeah,
two.
hi. Just
Still
to... I got you.
Thank you.
Where was I? Oh, yeah, the Flat Earth Society being... It's okay.
Just go for it.
I go for it? Okay. The Flat Earth Society being very private about it, although they do exist on Facebook and we have a page about that right now. We have it on the desktop ready to discuss that after this page. But this one is... And there's also multiple discussion groups. They're spread out, and there's not really one that claims to be, you know, the main one. There's so many split communities. I don't know if they have different theories about the flat Earth, but I do know a large majority of them attend this one event. That's almost like, you know, a Comic-Con or stuff like that, where they all meet together and they discuss, and they have public speeches, or people who come out from the community that are high profile flat earthers, if you can even say that. And they have like conferences and such like that to make themselves more believable. It's actually pretty funny. It's on YouTube, and I'm pretty sure a couple of YouTubers have covered that. That's where I've seen it. All right, we're heading back to Joe. Joe, where do you leave the mouse?
Oh, sorry.
I'm just like, okay.
Back to you.
Wait, it's on me now?
Yes, sir.
Okay. You're reading the article though, aren't you? I don't have the screen in front of me.
You're right. I'm so sorry.
That's all right.
All right.
Sorry about those technical difficulties,
Yeah,
guys.
sorry about technical difficulties. So we were discussing the theory of, like, you know, high altitude photographs. Why can't we see all the continents? Their claim is that curvature results from the fact that at the edge of the atmosphere we are looking down at an illuminated circular area of the sun's light. The observer is looking down at a circle always curved in 2 dimensions. When looking down at a circular area of the sun's light upon the Earth, we see an elliptical curvature. So I think that's where they're trying to explain the curve on the
Here, I
horizon
can
instead of
speak
it
about it.
being round. All right, you got it?
Here, I can speak about this. As me being an expert flat earther, as I am, as my hours and hours of spent pouring into internet research and anyway. So they have this idea, right? That the sun and the moon are these small orbs really close to the Earth, and they're just going like this. And for some reason, the light is really strong to provide weather, but really weak so that no one else sees it except for this tiny little spotlight. Makes sense, right? So then you have the moon, which is the same, but it's a lot weaker, and then they kind of go like this around each other, right?
Wait, that doesn't make any sense.
Yeah, it does. What do you mean?
No.
Are you a round earther or something?
I was talking about how if the sun was a smaller, less powerful, wouldn't it still illuminate the sides? And
No. See. It just illuminates this spot, Matthew.
Then what did we...
No. You're not thinking right. It just illuminates this spot.
My head, Joe. It hurts my head.
So, and then, you know, when you have lunar eclipses, right? It's just because you're viewing over here, and then the moon and the sun line up.
Doesn't make sense.
Yeah, it does. Oh, and by the way, Matthew, you know how there's this disc, right? The flat Earth? Well, obviously that has to be sitting on something. So do you know what's under it?
Like an island?
No. It's these 3 elephants.
Oh, we're back to that.
And
one.
these elephants.
I heard this one before.
See, the water falls off the edges, which the elephants then drink. And then when they have enough to drink, they then spill the water through their snouts up into the sky, and that's where we get rain. And then under the elephants is a large tortoise. And this tortoise, I don't know, he's kind of a cool dude. He's a tortoise. The elephants stand on him.
this is what I was talking about: sub-communities in the Earth. Like,
Yeah.
how crazy are you? How far are you willing to go within this?
Yeah.
Those are the sub-communities.
You can go down some crazy rabbit holes with this, man. It's kind of fun. it's really silly. So let's go to I would like you to challenge me. Find an article
Okay.
that you think would be challenging to debunk. Maybe in the general physics tab.
I was looking at the bridges.
Oh, do that one. That's fine.
Yes.
All right. Read it to me, and I will see what I can do.
All right. This is a quote from Sama Azent. Yes.
Well, we don't want quotes. We want.
Well, they're trying to explain the.
Okay.
Okay. So I read it, right?
Yeah.
Let me put it to my seat on the screen.
As a civil engineer, I have never taken the curve of the Earth into any calculation. There is no calculation for the curve of the Earth. You take 2 points and you build towards each other. In the middle, it may be some additional elevation of the roadway of the bridge and account for pitching, drainage of the water, and overall stability of some suspension bridges. But the ends are pretty much surveyed to be 2 leveled points, measured at an elevation height above sea level. The footings of the bridge must be level, the design will be flawed, and there's no curve, Joe. And I can't stay in character because I already know one of the longest bridges in the world does account for the Earth's curvature. And
Well, here.
Back to you.
I'll debunk this. So
It's not hard.
it's
not hard.
yeah. You were supposed to challenge me, Matthew. I'm
Sorry,
disappointed.
the bridges one.
I'm disappointed.
I had no prior research. I looked at bridges and I realized halfway what she was saying.
Oh my.
And I wanted to die.
So let me spill you some knowledge here, and I'm gonna quote our ninth grade engineering teacher, Mr. Fertet. If he's watching, cool. Sometimes he watches these. The Earth is flat in places. Who's to say? I mean, we can move dirt. We can make stuff. We can we can make this piano that I'm sitting at flat. We can make that desk flat. It's flat in places. We can make certain parts of it flat, but the overall, the mean, the average, turns into about an oblique spheroid, which is it's a little more bulbous at the equator. But anyway, I digress. When you're thinking of the circumference of the Earth, you're thinking of a very large number that I don't know off the top of my head. When you're thinking of the Golden Gate Bridge, I want to say it's a little less than a mile long. No, maybe it's a mile long, about a mile long, right? But anyway, it doesn't matter. You're comparing a number in the magnitude of times 10 to the 1 to a number that is times what? Times 10 to the 3rd, maybe 4th. I should really know these off the top of my head if we're doing a flat Earth.
Theory.
Yeah.
The Golden State Bridge is 8,981 feet.
So it's a little more. It's like a mile and 3/4.
Yeah.
Okay. What about the circumference of the Earth?
Probably wants to go to the-
Yeah, I thought that's what you were looking up. Anyway, you're comparing. Zoom into a tennis ball.
Circumference of Earth is 24,901 miles.
24,901.
Yes.
Okay. So you're comparing a number of, and you're saying that's miles or kilometers?
Miles.
Okay. So you're comparing 1.5 miles to 24,901 miles. I'm going to go ahead and guess that 1 mile is less than 24,901. Am I correct in that assumption, Matthew?
Mm-hmm.
Okay.
Just a little bit.
Now, if we have a circle where the circumference is 24 units, right? And we have, if we convert our Golden Gate Bridge to this 24 unit circumference circle, then it would be, let's see, 0.001 of a unit. Now, if you blow that section up to 0.001, and you know what? Let's go ahead and do this. Go on to desmos.com. And this is just to prove a point. We're doing this off the fly. I didn't plan on doing this. Go to desmos.com. Start a new graphing calculator.
Okay.
And then in the equation section, I want you to do 24 equals y squared plus x squared.
24 equals y squared plus x squared.
All right. Now make the window. You're gonna go to the crowbar or the wrench, not crowbar,
Yep.
in the top right. Make the window. Let's see. You're gonna want to zoom in to. Well, you know what? Hold on. Here, switch seats with me for a second.
Alright.
I can't explain.
I zoomed in and everything for you.
Okay. Why did it turn it into polar coordinates? That's weird.
I did.
Oh, why'd you put it in polar coordinates?
That look cooler.
Oh. How'd you change it to polar? Oh, that's how. Okay. All right. So let's see here. And actually, that's the radius. So radius is equal to circumference, which is 24 divided by 2 times pi. And that's going to be r. Alright. So there. This is our 24 unit circumference. Oh, hold on. How do I do... Nope, not that one. It's not switching. Oh, okay, there we go. I suck at this.
It's fine. I get the point though.
Alright. So here's our 24 unit circumference.
By the way, the mic is on me, right?
No, it's on me.
Okay.
So here's our unit. That's why I was trying to.
Okay.
Here's our 24 unit circle.
Mm-hmm.
Now let's do this mathematically. So let's zoom in on this point, right? If you look, as we zoom in, the horizon becomes flatter and flatter and flatter and flatter until here we are at the sections. You can see 0.001. Each square is 0.001. So theoretically, each one of these squares is a mile.
So the Golden State Bridge is gonna be.
So of course the Golden State Bridge is going to be flat. If that's a mile right here, that looks pretty flat to me, right?
It does.
So where's the curve? Well, let's zoom out.
It's all not
It's
proportions.
all
it's
around
scaling.
you. It's just a matter of perspective.
Matter of
We are
perspective.
so small compared to the Earth that it looks flat just where we're walking. But just go up in elevation, man, and you'll see the curve. They even have a picture. This blows my mind. They have a picture of the flat Earth. Hold on. Let's see. Form and magnitude. I've spent a little time on this website. Okay. They have a picture of the curvature right here. And they say it looks like a circle because there's a sun shining down a spotlight. Now, I want you to think about something, Matthew. I want you to think about something. If you have a circle, or let's say a sphere, because the sun's about a sphere. Now, when something emits light, in what direction is the light emitted?
Everywhere.
Every single direction.
Every single direction.
So,
That's
I want you to picture something.
a picture.
Picture a flat disk
Okay.
with a sphere right here, shining light. And it's shining light from everywhere.
This is exactly what I was trying to say before.
Now, there's going to be a line down, and then a line this way, and then a line this way, and a line this way, in every single direction.
Yep.
So what is keeping the light from going to any other part of the sphere other than the spotlight?
Joe, I have the answer for that.
Okay, well, let me put it to you.
Okay.
How do I... Okay, nope, that's me. There we go.
The answer is it's all telescoped in. You know,
Okay.
like a hollow cylinder.
Oh,
It's
right,
all
right, right.
funneled in, Joe.
Okay, it's a spotlight, exactly.
It's so simple, Joe. Like, I don't know.
Why didn't I think of
Why
that?
did you think about these things?
So, this leads me on to another question. And this is actually kind of an interesting... We should do this for a little bit.
What? Oh, like this?
No, yeah, just me and you.
Okay. Yeah.
So, it's just... Let's think about this. The sun is a sphere.
Yeah.
Mercury, a sphere.
Mhm.
Venus.
Oh, by the way, the Flat Earth Society agrees with all that. By the way,
No,
They
yes,
know there's-
yes.
They think
Yeah.
there's.
It's almost like they're thinking we're special.
Yeah. So, Mars is a sphere, allegedly, until Elon Musk sends people there, and then they'll, in a few generations, think it's flat.
Yeah.
All the planets: Saturn, Jupiter, Uranus, Neptune. Actually, I think they're considering Pluto a planet now, again.
Yes, I heard news articles. They're going back and forth. It's big publicity for NASA.
Yep, anyway.
It's almost like when they say,
Oh, an asteroid is gonna hit the Earth again. Oh wait, it's like 1,000 miles to the right, just to generate news articles.
And I don't think that's NASA. I think that's
Is that NASA?
definitely the news articles trying to get
That's the
clickbaity
news
titles.
article.
Because, you see, well, we're experts at that.
Yeah, I think, yeah.
So, that's exactly what it is. But I tell you what.
What?
Everything around us, it's all spherical, save for some asteroids. Now, why would the Earth be the only thing in the universe to be flat outside of galaxies?
Joe, I have a question.
Yes.
You should be asking, why do you think the scientists from, what was it, the 1600s, 1700s, why do they believe the Earth was the center of the universe?
Okay.
Their perspective was so small.
Yeah.
They didn't know a lot.
So I'll tell you exactly why they thought that.
Okay.
They haven't gone to space. They
you
haven't
go.
seen these other spherical objects from a telescope. And as soon as they did, and as soon as they actually took a closer look and spent a little bit of time outside of just physical observation from your tiny perspective, as soon as they took a little bit of time and research, they figured out, oh wow, it's a sphere.
Yeah. Oh, yeah.
Aristophanes.
Basic observation.
Aristophanes, Pythagoras. This is one thing I've never heard flat earthers debunk, and I would love a flat earther try and address this.
All right.
You know how when you're at the equator
Uh-huh.
and the sun goes around the Earth, right? The sun is directly overhead at the equator.
Yep.
When you go south, it shifts to being in the north side of the sky. And when you go north, it shifts to being in the southern side of the sky. And this is why in the northern hemisphere, like us, we only get more snow staying on the side of the mountains that aren't facing the sun. They're on the north side. So why, when you go either north or south, does the sun look like it's either to the south if you're in the north, or to the north if you're in the south? If you have a spotlight, it's going to be in the same spot everywhere. And in fact, I would go further. If you have a spotlight, on either side of the spotlight, it would appear to be either north and south. So you would get that 4 times on the Earth, not just twice.
I have a perfect answer for this.
Okay, let me... All you.
Alright, so the answer is
I thought you had the perfect answer.
the curvature of light, Joe.
The
You just don't-
curvature of
you just
light.
Don't, you just don't understand it.
Okay,
You just simply don't understand it. And when you could come back with me some formulas, but I won't pay attention to that.
Okay.
I'll believe what I believe.
That sounds like a solid argument.
Sound like nothing could debunk it.
Obviously. Nothing.
Checkmate.
Checkmate. That's it.
That's it. So, let's take a look. This I want to show you one. I want to show you one. All right. Oh, I gotta put it on that one. Okay. According to flat Earth theory, gravity is not the main force keeping us on the ground.
Don't tell me it's spinning.
Hold on.
Don't tell me. Don't
Instead,
tell me. No, Joe.
there is a force
That's
that
spinning.
produces
That's spinning, right?
identical effects as observed from the surface of Earth.
These
This
guys
force
spin.
is known as
These guys
universal
spin.
acceleration.
No.
Objects on the Earth's surface have weight because all sufficiently massive celestial bodies are accelerating upward at a speed of 9.8 meters per second squared.
So you're saying
You think you can point out the flaw in that, Matthew? His face.
Wait, they're saying we're like in an elevator.
Yeah.
We're going.
We're going upwards.
We're all accelerating upwards, and we're just staying.
Yeah.
But what do we just like? I don't know.
Yeah. So one would think, given acceleration is the derivative of velocity, correct? And velocity is the integral of acceleration. Given that acceleration is the rate of change of velocity, and velocity is the speed at which something is moving in a given direction. When you have an acceleration of, let's say, 9.8 meters per second squared, which doesn't explain why gravity isn't uniform, that acceleration is different on different spots of the Earth. Theory of relativity explains why, but not flat Earth theory, but that's a different story. So, let's think about something. If you are accelerating constantly, then that means your velocity has a constant rate of change, meaning it is constantly increasing. Given that the Earth has existed for, and depending on there are some flat earthers who think the Earth is 2,000 years old, and there are some flat earthers who think that the Earth is millions of years old or billions. So let's see. For even at the lowest end of 2,000 years, you're constantly accelerating. You're constantly increasing your speed. Do you think by even just 2,000 years, you might probably be pretty close to the speed of light, at which you have Einstein's theory of relativity, or his famous equation, E equals mc squared. The more energy something has, the more mass something has, the less close it can get to the speed of light.
So they're saying we're constantly
Accelerating. And so my point is,
For
do you
what?
think that maybe we would be really close to the speed of light by now? And
Yes.
if that were the case, why are we not all just turning into energy?
Dead. Wait, no.
Why are we okay? What made them think we're accelerating? Like what's
Here, I'll explain
accelerating the Earth?
Well, I don't know that they say what is accelerating the Earth, but they let's see.
It's forever accelerating?
Okay. Oh, hold on.
Oh.
They address my point. It is a common misconception that if we are to continuously accelerate over time, we would eventually be moving faster than the speed of light.
Yeah, Joe, misconception. Get it right.
This is, of course, incorrect, as nothing with mass may do so, which is exactly what I said, which
Nothing
just
with
proves my
mass
point, but
may do
okay.
so.
According to special theory of relativity, the Earth can accelerate forever without reaching or passing the speed of light. Oh, please enlighten me. Relative to an observer on Earth, more specifically, an observer who recently left the Earth, example, a person who jumped up, the Earth's acceleration will always be 1g. Okay. Relative to an inertial observer in the universe, however, the Earth's acceleration decreases as the velocity approaches c. What?
Are they trying to bring math into this? Does it make sense?
Let me read that again. Relative to an inertial observer in the universe, however, the Earth's acceleration decreases as its velocity its velocity approaches c.
Wait, it's saying it's fluctuating there?
It all depends on our frame of reference to measure and explain the.
What? Joe, is this hurting my head? What?
So let me get this straight.
What is this?
Let me get this straight. No, that just doesn't make any sense at all.
The Earth's
So-
acceleration is just decreasing and going back.
Hold on.
Is
No,
that what it's saying?
What is it saying? Because it doesn't make sense.
so
Wait, Josh is
let
commenting.
okay. So let's break this down. Let's break this down. So they're making a false equivalency here. They're saying because mass cannot reach the speed of light, and given that the Earth must be accelerating up at 9.8 meters per second squared, it must mean that the Earth won't reach the speed of light. That's the equivalency they're making, and it's false because it's making the assumption that the Earth is accelerating upward. However, we know for a fact, and it's been tried and tested and true, that when you accelerate something, it moves faster. And it doesn't stop. Now, they're going to bring the Lorentz factor into this, and I do want to read this because this is a really important point. Well, so I want to see if they make this point. Special relativity, also known as special theory of relativity, is the physical theory of measurement and inertial frames of reference proposed in 1905 by Albert Einstein after considerable and independent contributions of Lorentz and other people. So, let's see. It generalizes Galileo's principle of relativity that all uniform motion is relative and that there is no absolute and well-defined state of rest. And that's exactly right. Like, me sitting here, I might be at rest, but I'm actually rotating on the Earth, and the Earth is rotating around the sun, so I'm not actually at rest. It's relative. And the atoms inside me are all moving. That's what it means by relative. It doesn't mean that to an outside observer, I look like I'm... Well, actually, no, it does. To an outside observer, I look like I'm moving, but I don't look like I'm moving right now. And that would actually track if they're staying consistent with their theory where... if it's accelerating upward, the person wouldn't think they're moving, but to an outside observer, they would be. But that's not what they say. They say to an outside observer, you would look like you're standing still, which does not track. So anyway, let's keep reading. This theory has a wide range of consequences, including counterintuitive ones such as length contraction, time dilation, and relativity of simultaneity, contradicting the classical notion that the duration of time interval between two events is equal for all observers. And this is true. When you speed up, or when you get significantly closer to the speed of light, the time for everything around you speeds up, whereas you perceive time the same. Or you could say that time slows down for you and everyone else stays the same. It just depends on which observer you are. And so they nail this. This is actually right. So let's see. Special relativity reveals that c is not just the velocity of a certain phenomenon, namely the propagation, blah, 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 but rather a fundamental feature of the way space and time are unified in spacetime. So they nail that. That's right. Consequence of this is that it's impossible for any particle that has mass to be accelerated. That's perfect. They nail that on the head. This is a great explanation right here. So why doesn't the Earth's velocity reach the speed of light? Well, let's see. They have a piecewise function here. So let's see. Let's define the event to have space-time coordinates. Okay. And in the system S, and okay. Okay, that I can see that. Okay. So time is going to be the Lorentz factor times time. Okay, so you have a differential equation there.
Beautiful.
Yeah, so you have a couple partial differential equations, okay. And that, so why does X get that but Y and Z don't? I'm a little confused at where you're getting these. The Lorentz transformation specifies that the coordinates are related the following way. Okay, well, I'll take your word for it.
Oh, you're agreeing with their logic?
Well, let's just see where it goes. Let's just
see.
see. I'll give them the benefit of the doubt.
Okay.
So they got that right. That's the Lorentz factor. Okay, differential equation for velocity. Yep, they got that partial differentiation right. Integrating for velocity. Yeah. Let's see. Okay. So then they substitute in the Lorentz. Okay. Sure. As t goes to infinity, you get c. Okay, yeah. As you can see, it is impossible for dark... Okay.
As you can see, it is impossible for dark...
Okay, so let's break this down.
Oh my god.
Let's break this down.
We made a big jump here.
Let's break this down.
We made a little jump.
As the limit of t goes to infinity, v equals c, which basically... Oh, I didn't mean to click on that. So, and that's... Given their equation, that looks about correct. When t goes to infinity... Infinity squared is infinity. 1 over infinity is 0. 0 plus a constant is a constant. You get g squared is g. G divided by g is 1. And then, well, wouldn't that be 1 over c? But am I doing that right? I might not be doing that right. Oh no, I don't know. But that's about right. That the approximation they get there is good. When time goes to infinity, if you're constantly accelerating, then you're going to. I'm putting my hand in front of the camera. If you're accelerating constantly, and it doesn't stop, you have a constant acceleration for an infinite time interval. Then as t approaches infinity, then your speed is going to reach c. They got that right. Now they make a little bit of a jump here. As you can see, it is impossible for dark energy to accelerate the Earth past the speed of light. And I would take this a step further, and I would say it is impossible for anything to accelerate any mass past the speed of light that we know of right now. They bring dark energy into this. I don't know why.
It was a big leap.
That's
Like,
that's a
where did
little.
that come
I don't
from?
know where that came from.
Yeah, exactly.
So why? So I want to know how that proves that the Earth is constantly accelerating. Because again, they're making this equivalency that, given the Earth is accelerating and that you cannot break the speed limit of c, then it must mean that the Earth doesn't break the speed limit of c. You see what they're doing there?
Nope.
No? Well, it's quite clever. They're putting all this math, which people aren't going to take the time to read, even though it is correct.
Even though it's correct.
They're saying they're making this is their error. I mean, technically that's true. The line I highlighted, but
Okay.
and yes, the velocity does not reach the speed of light, and it can't.
Mm-hmm.
But you have a constant acceleration. You have a constant acceleration.
Yeah, it's
When you
wrong.
have a constant acceleration with an interval of t, it will reach c. Or an interval of infinite time, you will reach c.
This is
and
infinity.
It just breaks.
And yeah, like you said before, it all goes back
But
to what you.
They make this false equivalency that given that the Earth must be accelerating up and you can't break the speed limit c, well then it must mean that the Earth just doesn't break the speed limit.
Which doesn't make
So, explain to me why the Earth doesn't break the speed limit,
sense. Yeah.
and maybe we can have a conversation there. Explain to me why. I understand that it's impossible,
We need
and
to
I agree
review-
with you. In fact, I agree. It is impossible to accelerate any mass to the speed of light. What are you doing?
Sorry, I put my foot on
Oh,
there. We need to interview a.
we need to
real
interview.
flat
So
earther. You're not gonna be able to find one. They're not gonna.
so
want to
let's
talk.
look at this. Explanations for universal acceleration. So the first one is dark energy, and for those of you who don't know, dark energy is the proposed. It's a hypothesis for why the universe is expanding in all directions.
We covered this 2
We
podcasts ago.
Yes, we did. Yes, we did. So you can go refer back to that if you wish. So let's see what they say here. This model proposes that the disk of our Earth is lifted by dark energy, an unknown form of energy which, according to globularist physicists,
Yeah.
makes up about 70% of the universe. The origin of this energy is unknown. So this is what I see with even like sci-fi things. They just kind of take dark energy and just explain it because nobody knows anything about it, and it's a hypothesis, and there's not really any kind of anything involved with it.
What you're saying that you could, like, people could apply their own reasoning or logic behind it.
Yeah. So, first of all, this you're making an assumption. First, that the Earth is flat, which I don't agree with. Second, that dark energy can move things, which is not what dark energy does. It expands space-time. Maybe you could make the point that the flat Earth is constantly expanding and that's causing an acceleration, but you'd be kind of hard-pressed on that one. So let's read the next one. Davis plane. This model states that there is an infinite plane of exotic matter somewhere below the disk, pushing in the opposite manner of traditional gravity.
So this is what I was trying to
So it makes more
It's
sense to
lifted by
you.
dark energy.
It makes more sense to you to have a plane of antimatter below a disk of normal matter than it does to just have a sphere in space that tracks with every other observed natural phenomena that has gravity, just like every single other natural phenomena that's been proven time and time again. This makes more sense to you.
Can I say something?
Absolutely.
It feels like they're really trying to push it, like really trying to push it in and trying to put formulas, math into it, and trying to make it make sense, and it never will. And even if they try to put in stuff that doesn't make sense, that it's only theory, and try to make their own like sense about it, eventually we're gonna find out what that is, and it won't make sense again. Then they're gonna keep reaching and keep reaching. That's all.
So I want to read this next part.
I got it.
Variations in gravity. I was talking about this a little bit ago. Why does gravity vary with altitude? I like their answer. According to the model of celestial gravitation, which I've never heard of that. I've just heard of theory of relativity, but whatever. The moon and stars have a slight gravitational pull. Yes,
Yeah. No way.
everything pulls on everything based on Einstein's theory of relativity. It's the warping of space-time.
Ooh, you going for that one?
So this statement right here is correct. The moon and stars do have a slight gravitational pull on the Earth. The moon is a lot bigger than the stars, and the sun is a lot bigger than the stars, but I digress.
The sun is a lot bigger than the stars. You mean closer?
Yeah, well, I mean the gravitational pull is a lot bigger.
Gravitational pull. I thought you were saying like in scale.
Sorry, greater. It is a lot greater.
Okay.
This is given as an answer to tidal effects and what?
This gives an answer to tidal effects and variation.
No, it doesn't. So what?
Wait, the moon does give tidal effects, no, does it not?
Yes, it does, but that's so the moon and stars and stuff pulling on Earth.
The stars.
Yeah, it can do tides. That's well and
Yeah.
good, but the main reason that
That
I could be
variation
wrong,
of
but I believe the
gravity
variation of the
altitude.
reason that it varies with altitude is because you're becoming either closer or further away from the center of mass of the Earth. The closer you are to the center of the mass of the Earth,
Yeah.
and you can look at Einstein's theory of relativity or Newton's gravitation equation.
They're trying to pin it on the moon.
If you are closer or further away from something, that affects how much gravity pulls on you, and that is defined as a force. And force is equal to mass times acceleration. So every single mass will feel the same acceleration from the same. The Earth's mass is the same, and since the Earth's mass is the same, and given that everything is about the same altitude here on Earth, relatively to the size of the Earth, everything's going to be about the same acceleration. And you can actually prove this, and I could even do the math for you right here using Newton's law of gravitation, but I won't. You can look it up for yourself. But the fluctuations is just because you're either slightly above or slightly lower. And yes, the moon and the sun and the stars do play a little bit of a role in that, I suppose. So let's see. Other models reject the concept of gravity entirely and question whether those slight variations in gravity actually exist.
But they do.
Okay, so
You can measure
your
them.
first model, you're saying the that gravity exists, but just the Earth doesn't do gravity. It accelerates upwards. And then your second answer is gravity doesn't exist and there's no fluctuations in it.
Different theories.
I would like to
Talk to
someone
Don't
and
we
explain. Yeah. All right. So let's see here. All right. Well, they just go on to say stuff. So I'm gonna switch it around. We're gonna do some philosophy and I'm gonna interview you, Matthew.
Oh, we're here?
Yeah, we're here.
Okay.
But first,
get my mind
before we do that, we're gonna take some chats.
Oh, we only have like 2, but one of them doesn't make sense.
Okay, well let's let me bring up the stream here. Okay. If the Earth was flat, would I be able to have the opportunity, just the opportunity, to get better service signal? I get that T-Mobile connection, and it's non-existent. So
Try explaining the second.
I get that it's trying to be a joke, but I'm actually gonna break it down.
Okay.
The flat Earth doesn't mean that the Earth is entirely flat either. Actually, their model still does include mountains and stuff. So unfortunately, your T-Mobile is still gonna have the same service.
Even from Flat's perspective.
And I'm not gonna read that second comment, but all right, Matthew,
I don't know if I'm ready.
you ready for this?
Nope.
All right, I'm gonna ask you a series of questions, and I just want your honest opinion. All right.
Okay. I'm ready.
All right. Do you know what utilitarianism is?
You explained it to me once, but I need a reminder.
Okay. So utilitarianism is basically the ends justify the means. And then there's also let's actually before we get to that, let's start with this. There's moral absolutist and moral relativist, or relativism and absolutism. Relativism means that truth is derived not from some absolute authority, but rather from agreements of society and agreement of society. Moral absolutist says that there is definite good and definite evil, and it's not just based on perspective and whatever. So first, I want to say, are you a moral absolutist or a moral relativist, and why?
Well, my morals are based off of course, what God has given us.
Mhm.
So it's not really. Is it absolutist if I kind of base it on those laws?
Well, is there a definite truth and fact? Is there a definite good and evil, or is there just gray area? There's no evil or good. It's dependent upon your perspective and its use.
There's a definite good and evil.
Okay. So you would be an absolutist.
Yeah.
Okay. So why is that?
Sense.
Yeah, why is that? Well,
Based off
so
my-
explain.
Okay, based off my religious beliefs, God has already given us what is good and evil. You could do this. This is breaking a commandment. This is a sin. Follow these rules given to you. There's no in between for that. You either you did it or you didn't do it. But there's always gonna be a complicated scenario where you would really have to break it down of some goods, some bads that happened in that timeline, and it could not be defined by good or evil.
Okay.
Does that make sense?
Yeah, that makes sense. There's always going to be a situation where you just have to choose the lesser evil or the greater good.
Yeah.
Yeah, I see what you're saying. That, and of course everything isn't just black and white.
It
But-
can't be.
Well,
This.
I want to
This
quote.
earth is
I
too
want to quote The
complex.
Witcher.
Okay.
That
Ooh, your favorite show.
evil is evil, lesser, greater, and middling. That choosing the greater of two evils, I would rather choose not at all. Or I don't know what that quote's from, but it's from something. So, I have a follow-up question. Given that you're a moral absolutist,
Okay.
are you...
You already knew what I was gonna choose.
Yeah, I did. I digress.
Yeah.
Are you utilitarianistic, meaning that the reason something is good, or something is good because of its end use, or are you I guess what would that be, purist? Is maybe the opposite of that. I'm probably making that term up, but where it's either it's not just the use of something that makes it good. So what do you
Yeah.
think about utilitarianism is my question. What the ends justify the means. The good is determined only by the use of something. What do you think about that?
I don't think the ends justify the means.
Explain.
Well, I could go in all the scientific achievements that German Nazis have made
Yeah.
through the wars. Look at their methods. Look at the results. Wow, we can look at all the benefits it gave us, right? For medicine, blah, blah, blah. But then you look how we got it, and it really just didn't justify it at all.
So I'm gonna challenge you.
Yeah.
I'm gonna give you a scenario.
Oh, give me the scenario.
You have a son,
Okay.
right? And let's say a family, a wife, and your son maybe is your only kid. How about that?
Okay.
And there is a horrible pandemic. How about that? There's a pandemic going around, and it's much worse, much worse than the pandemic that shall not be named.
Killed my son.
And you're in a quarantine camp because, or maybe you're in a area that's designated that doesn't have the virus, and the whole world around you is falling apart and degrading, and society's collapsing. And the doctors come up to you in this spot, and they say, "We've run the blood work on your son, and he is the only human alive immune to this disease, and we can make a cure for this disease and save humanity."
Is this The Last of Us?
Yeah, pretty much.
Okay.
And we can save humanity if we take his blood. And you say, "Well, how much of his blood?" And they say, "All of it."
Okay.
So you would basically be sacrificing your son,
Mm-hmm.
or to save humanity, or just the chances of everything's left to the chances. So what do you do?
It's almost like God sacrificing his son for the cross of the sins of humanity. But also I can make it so it's my son's decision if he wants to do it or not. And if he says yes, then we'll do it. But I can't make that decision for him. So it would be out of my hands.
So
Oh, you're gonna say he's unconscious?
what?
You're gonna say he's unresponsive?
No. That'd just be no. So no, that'd be a pretty similar answer to what I would give. But my point in asking that question is sometimes the ends do justify the means, and it's not always just black and white. But we all at the end face judgment by our Creator. At least in our opinions and our beliefs.
Yeah.
And who would enter the gates? Someone who has done nothing but good in their life, or someone who has done more good but also more evil? And I wonder. And I don't know that there's really a right or wrong answer to that. And I mean, I truly believe that
I think both of them.
God is merciful,
Mm-hmm.
and they would both make it in. But that's why I brought up that question, just to get people thinking. So I wanna ask you something else.
All right. Listen.
Have you ever heard the quote from Frederick? I'm probably gonna butcher this. Frederick Nietzsche, and it's God is dead,
Okay.
and we killed him.
Oh, I've heard that one before.
So basically, he was referring to the popularization of secularism and of replacing God in everything, pretty much, society, school, everything. And Jordan Peterson, who is one of my favorite people, he makes a point that there is a religious desire inside of a person, and you have to fulfill that religious desire with something. And when it's fulfilled by religion, usually it enacts people to do good and to better themselves. Depending on, whatever. So I want to ask you this. Our society is becoming increasingly secular, increasingly less religious, and that can lead to things like nihilism, secularism, which do you know what nihilism is?
The belief in nothing.
It's basically that there is no meaning, there is weird, stuff like that.
Yeah.
And then secularism, there is no. Actually, I'm not too familiar. I'm gonna stop using that term and just say atheists. But so I wanna know what is your take? Where do we go as a society when we have replaced God with celebrities, with politicians, and with things of that nature?
We restart humanity.
no,
We put 2 clones in a pod, and then okay.
I'm serious.
Okay. Well,
I know I'm
what
putting
can
you
we
on
do?
the spot here.
No, I know. That's why I have to think about it. It's a complicated question. What do you do with that everything's replaced? We have to start small. It's an every person thing. Every person has to commit to this. It's not like, oh, one person gonna change everything.
So
You have to spread
sorry.
religion. You have to spread his teachings, and hopefully it reaches their ears.
So I want to ask you a follow-up question. What are people replacing it with? What are people
I got it.
replacing religion with these days? And is that a good thing? Is it a bad thing? And what do you see the effects of that? I know you probably know people who have replaced religion with something else, and I just want to know your perspective on the matter.
They replace it with escapism.
Okay,
that's
interesting.
They replace it with escapism. They want to run away from the problems. They want to run away from everything that hurts, that gives them pain. And through escapism, you feel nothing. You're out. You're kind of out of body. You don't have to deal with everything. And through escapism, well, humanity, we always desire social interaction and stuff. Escapism doesn't provide that. It gives us temporary relief. It's a temporary fix. Like we always do. Like we want our constant gratification, like that, or instant gratification. I'm sorry. And escapism doesn't provide human contact, and in the real world, how do I phrase this? It's so complicated. Social contact or social interaction with other people, love from other people, is not guaranteed. And when it's not guaranteed with someone, it hurts them. Why won't they love me back? Why won't they? Oh, I'm going to go back to escapism. Oh, it provides me nothing. It's an endless loop and it's suffering. And through a world where we have, we should be thankful we have a world with a possibility of love. And you should be taking those chances, even though they hurt you, to find that love and to find connection with other people, or else you're just gonna be empty, and if you're gonna waste your chance through escapism, and it gives you nothing. It leaves you empty, but it gives you that slight little happiness of escaping your problems.
That is really interesting. I honestly didn't expect you to answer that way. That's awesome. So, and I want to further that. We sometimes we find our greatest meaning in pain and suffering.
There we go.
And that's incredibly powerful. When there's, I'm obviously religious and Catholic, but that's where you find God, and that's where you find love, is in pain and suffering. And just pushing that aside mitigates all of the good that can come from the bad. You can't have good without evil. God gave us free will, or if you don't believe in God, we have free will. And because we have free will, we can either choose to do good or choose to do bad. And although there is pain and although there is suffering, you can either choose. You become the person based on what you choose in those situations.
Exactly.
When you're in pain and when you're suffering, if you choose the easy way out, the evil way, or if you choose the hard way and the righteous way.
There you go. People are choosing the easy way out.
And so what is the easy way out? What do you think? You said
Not dealing with it,
escapism,
running away.
not dealing with it, running away. I would wager that it's not necessarily running away, but it's subverting it. And not only subverting it, but dragging other people down with you almost. In a sense that if I'm suffering, everyone else needs to be suffering too. And we see that
That's
a
exactly the
lot.
show I watched.
We see that a lot these days. With, just I'm suffering, so you need to suffer too. But everyone is suffering. Everyone is in pain. Everyone has suffered. Everyone has had pain. And you can't justify bringing someone down because you don't know their past. You don't know, they might already be suffering or are already in pain, and just by bringing them down, you're bringing them down even more. It's like I said, you become the person, you become the person that you become based on the decisions you make in the worst times. And the other thing that people are replacing it with is idolatry.
Idealizing others.
Yeah, idolizing celebrities, politicians, or ideas even. We have a huge rise in, well, we have a huge rise in socialism in the United States right now. And a part of that,
The Red Scare.
yeah, Matthew says the Red Scare.
It just reminded me of it.
Yeah. So, I digress. We can keep talking about philosophy. Maybe we'll do.
Isn't this season supposed to be philosophy?
It was supposed to be philosophy, but I wanted to talk about flat
We can talk about
earthers.
anything we want.
Yeah, it's our channel. We can do whatever we want. So. All
You
right.
agree on my escapism though?
That was
It's
a
evil.
really interesting
Escapism is
take,
evil.
and I'd never heard that before.
Never heard of this?
I'd never heard that before.
Run away from your problems is bad for everyone, including worse to you. And the only true happiness you could get, the only person. Oh, you want me to go more philosophical?
Sure.
Okay. There's different versions of you in different people. Have I told you this before?
No.
There's different versions of you in other people, right? They only see what you show them, right? No one is gonna know the true self of you, except you. You're the only person that's gonna know everything. You only give out as much as you give out, and the closer you get to a person, the more it's gonna hurt, right? The more you're like, oh, this is uncomfortable, but I'm showing a truer version of myself to that person, and it feels good at the end, but it was painful to get there, and people don't want to do that. Disconnect from other people, escapism again, running away, and
You might need to get closer to
okay. And the only version of yourself that's true is the one that you know. You're the only one who's gonna know your true self, and the only way you can't be seeking validation from other people. You have to find. You give yourself your own meaning. That's it. That's it.
Wow,
Yeah.
that's deep. That's an inside joke. I'm sorry for those of you who don't know, but I want to take that a step further
Okay.
and say you don't become your own meaning necessarily, but you get, in my opinion, in my belief, you get meaning from loving others.
There we
You get meaning from
go. Isn't loving other people loving God?
yes,
There
you get meaning, you ascertain meaning from willing the good of another and desiring to be in relationship with that other, and that is ultimately the definition of love in my opinion. You will the other person's good, and that doesn't always necessarily mean it's in your best interest, and it's hard and it's painful and it's difficult to do that. But that is ultimately where you find meaning, and that's ultimately where I think good lies, in loving thy neighbor.
we go.
And that ultimately, if you take anything from what we've said, and if you take anything from any kind of religion, treat others how you want to be treated, because you don't know what they're going through. And in addition to that, love thy neighbor as thyself. And if you do that, it won't make everything better. But I guarantee you, you will be more fulfilled and you will find more meaning in your life. And you just make the world a better place, so that's a plus. We are in a time right now where people are so caught up in my way, in instant gratification, in this is what's best for me, my way. And if you put your ego aside a little bit and desire to be in relationships with other people, not meaning like romantic relationship, but like friendships or like any kind of
Family,
relationship, family, friends,
anything.
loved ones.
Yeah.
I think that's how we fix the problems we're facing. It's not from running away from our problems, like you said. It's not from idolizing celebrities or politicians. It's not from stamping down this idea that we have in our heads that is so foundational to us that it hurts when other people challenge it. It is finding meaning in the pain and loving despite the hurt.
Yep. You know, that's exactly.
Joe, can you speak for a second?
Yeah, you're on.
It's exactly from where I got all these ideas and I
Uh-huh.
started thinking about this and I kind of changed my mentality. You're not gonna like my answer.
Uh-oh.
It's from an anime.
Oh, gosh.
But it's a very old one. A lot of people have watched it. Recently, Elon Musk tweeted from he watched it before and he was tweeting about it, and I was like, oh, okay. It's just a philosophical one. That's all.
Okay.
And I really enjoyed it, even though it was very painful to watch.
It sounds like it's got some good ideas in it.
It really challenges the person, and it challenges you while you're watching the show. This is a form of escapism. Like it goes insane. It goes insane.
So I want to get a little Inception-y with you.
Oh, Inception. Okay.
So are you enacting an escapism by escaping by watching the show about escapism?
Yeah, I was. I wanted.
There's so many, man. There is so many distractions in life, and I
feel like we carry it around us now.
I know we have the entire knowledge of humankind in our fingertips, constantly, and we have constant communication with everything. Which it's I think communicating with other people is a good thing, but it definitely has its downsides. But we've just there's so much instant gratification and so much, and I catch myself doing it all the time, like spending way too much time on YouTube.
Same.
That is my vice,
social media.
man. Yeah.
Except when you're talking to friends on social media, that's good.
Yeah.
But scrolling, doing other things.
It's terrible, and it's terribly addictive.
What are you getting out of it?
Well, when I watch YouTube videos like for informational stuff, like
That's
learning
it.
IT stuff or learning, I don't know, like circuits. Learning is great,
That's
but
not escapism. You're facing your problem.
yeah. But when then you start to go down the rabbit hole of, oh, let's watch this guy screaming at a video game for 2 hours, and it's like, is that really worth your time? And
To an extent, it could make you happy for a moment.
yeah, for a moment.
For a moment, but it's all in moderation. It
Yeah.
goes back in moderation. You do too much of it, what's the point? What are you getting out of it?
Well, and honestly, it's just a waste of time.
There you go.
And but anyway, we've gone a little bit over.
Anyway.
Just a little bit over. So, any last? That was a good conversation.
Yeah, it
Well,
was.
the next episode, I'll do some research and some philosophical stuff. I kind of like this format
Yeah.
of just talking conversation of just about philosophy. So
Yeah.
we'll do that next episode. I really like this.
It's a bench.
Yeah, I need to get a different chair for there. We got rid of the rolly chair.
Oh, okay.
So, any last comments?
Escapism is bad. Catch yourself doing it.
That's it? All right. Well, like I said, if you take anything from this episode, it's that have some grace, and maybe you'll end up bettering yourself because of it too. But anyway, thank you for everyone for tuning in. We never did the intro ads.
Bruh.
Anyway, I'll do them right now.
You're right now.
Let's see, it's these ones.
Joe's
So,
the intro this time.
Yeah, you're gonna have to do the ads because you're in the seat.
Oh, really?
All right, you got it?
I think so. I've seen you enough time to do it. Is it up?
No. Hold on. Let me fix it. I'm gonna put it on you for a second. Stall for me.
Stalling. No, escapism is bad. That's all I'm gonna say for the next minute that you're gonna be fiddling with pushing buttons over there. See, if I was over there, Joe, it'd be done in an instant.
All right,
We
you're
switched chairs.
You're up.
Okay. So basically, subscribe down below. Check us out on all platforms we have listed above. On Spotify, check up on YouTube. Comment down below on the video when it is posted, and check in on our lives every Monday at 8. That's all.
Yeah. And you can. Oh, that's Matthew. Hold on. And you
Check our
can.
Instagram.
Yep, you can follow me at joe.czol on Instagram, where I post about usually building a cabin, and that's about it. That's about all I post there, except for ads for this
Pride
show.
and joy.
Yeah, I love building that cabin. But anyway, we've gone pretty late, and so thank you guys for tuning in. Make sure you. Well, no, that's it. We'll see. We'll see you next week. Yeah.
See ya.
Oh, hold on. I forgot to switch to you. Hold on.